Hi everyone. You see here in front of us is a little device I've made. And it's a lifting device, a little different design from standard rack and pinion that we saw in previous videos, and the extending lever video and whatnot. But this one here is more based on kind of an elevator type system, and the difference in this one from the previous rack and pinion is the racks are stationary versus traveling in the pinion gear, and the pinion gear is attached to the carriage. This whole piece right here being the carriage, and that travels up and down our rack assembly, as you can see. Again, like I say in all the videos, we start a drive system. It's very similar to what you've already seen now. We have that brass coupler that has the spline that attaches to the output shaft of the motor, and I created this mounting bracket just using some of my 1/4" plywood, and I mounted my motor into this opening that I created by measuring the motor and positioning my shaft to attach to my gear to the axle that goes through both of these components that are making up my carriage. One thing you're probably noticing by now is that I have my plywood here. Like you can see, it's epoxied on, make my 90-degree angles to make the mounting surface for my motor. But this is plywood, and when you put screws into the side of plywood, you can actually see how it's laminated. What happens is you separate those laminates, and it causes the wood to split. So to combat that, what I did was I made this little aluminum shield that I bent at 90 and then back over itself to create almost like a bracket within the drive bracketry to keep that from happening. So that you see here, my screws are actually going through the sheet of aluminum and then into the end grain of the plywood. Plywood's a great material. It's not limitless though when you start playing with the sides where the laminates are. So that's how I combated that, and it seems to be working pretty good. I have a spacer block here to maintain my gap because my slide is going to be sliding within this gap in the vertical. And just like on the 4-bar rack mechanism, I maintained the centers of my output gear to my idler gears, which are right there. And again, they're all just sandwiched in this. I use similar construction that I did with the 4-bar mechanism. I got bushings, and I'm using the hub of the bearing as a bushing on one wall and a normal 1/4" bushing on the other wall. And I have my axle shaft. This is ×2, right? And I have a washer on this side here because these are going to rotate. My shaft collars are going to end up rotating. And using it in this manner is pretty cool, because if I need to get to my gear now, it's just a matter of taking these shaft collars off, and this whole plate will just disassemble, and I can either change my gears or do the maintenance that I need to do without disassembling the entire unit with these push nuts that I used on this side. If I used them on both sides, then it's a little bit more work to get it apart if I needed to. So I was thinking of that in advance. If I had to take this apart, how would I design that? Okay, so it's pretty straightforward. The carriage, the gears are contacting the rack on this side, the output gear. The idler gears are contacting here. And if you notice, I have 3 points of contact, right? I have the drive gear, and then I have the drive gear is centrally located to my idler gears. What that prevents, or limits I should say, is carriage when it's changing rotation and change direction. The carriage would have a tendency to rock back and forth if my idler and my drive gear were all in the same plane. But by making 3 points of contact, I minimize it. I still have a little bit, and there would be ways to get around that. You could stack more idlers, but then we start losing the usefulness of this entire length of bracket here. So that hopefully prevents the racking. To mount this, I wanted to maintain my perpendicularity and my squareness to the base. So what I did was I took my 3/4 inch piece of fir, and I don't know if you can really see it all that well. I took my file and I filed a notch so that my rack and pinion assembly would sit inside of this notch right here, if you can see that, and that maintains my perpendicularity and squareness to my base. So that's kind of fun and pretty easy to do. Like I said, it was just done well, and then mounted it to this base here. One last feature that you haven't seen on any of my devices yet, but you've probably seen them in your kit. These little switch apparatus that I don't have wired in here, but you could wire those to your Arduino setup, and that would limit the travel. So as the carriage comes down, it makes contact with that switch bar right there and turns the carriage off. And same thing in the other direction. As it travels up, it would shut it off when it reached its limit here. These are called micro switches. They can be called limit switches. But they're actually handy, and if you think about it, if I had a device to this carriage and I wanted it to stop in the same location each and every time, I would position my micro switch in such a manner that it would make contact, and whatever device I'm driving with this carriage would stop exactly in the same spot each time, so you have repeatability. Sometimes that's really necessary to have, and it's just a matter of wiring one of these micro switches and positioning it in where you want it to stop. So those are kind of nice. I put them in place. Like I said, I didn't wire them in, but just showed you how you can use those, and makes it a little more versatile. You don't have to do as much program. Just position that, and it stops when it makes contact. Oh, I think that's about it for this guy. I'll plug it in and see how it operates. It's kind of useful. It's a little repetitive for raising and lowering things like, you know, the rack and pinion or the lever, but it's certainly another option that we could have. So let's see how this guy goes. Oh, I'll hold this at an angle so you can see it. So that's kind of fun. This is a good view here. So you can see how it travels up and down. The gears moving in there. See my drive moving. You can also see when I make contact with my micro switch, I'm going to raise it to its extreme here. Picture that wired into your program, and there it is. It stops right there. And same thing in return. It stops right there. So another way of making a little device, I made this little popsicle stick thing to replicate maybe a device that you're using. And if this was at its extreme, low extreme, and I put this device in here on my carriage, I mount it to my carriage. As I travel, you'll of course, you'll see that as the carriage travels, my popsicle stick extends, and essentially I've gotten probably another I don't know, maybe 40% of the overall height from what I built. So, almost see that, huh? So that's that. This was kind of born from, it started off as like a cog rail system, and as I built it, it kind of evolved more into an elevator. But certainly something that you might consider, or even draw some of the components from and use it in a part of your design. So hopefully that helps.